All right. Some 5-card poker probabilities using combinatorics. You can be dealt 5 cards from a standard deck. In how many different ways can that be done? How many different cards are in a deck? 52, and we're going to make a hand of 5 cards. The order that you're dealt the 5 cards doesn't matter, so this is a combination. So 52, choose 5. Of the 52 cards in the deck, choose 5 of them, your initial 5-card hand. So there are just less than 2.6 million different 5-card poker hands. 2,598,160. When we start looking at some probabilities here for the next set of 10, for these next different poker hands, this is out of how many ways I can draw these different hands. So we're always going to be dividing by this value in the denominator for all these probability calculations moving forward. Some experience than others. I've got lots of different types of 5-card hands up on the board. Let's talk about these hands, how we could use combinations to figure out the number of possible ways that these hands can occur. What is a royal flush? The highest possible, the best possible poker hand. Anybody know? A royal flush. A royal flush is a straight 10, jack, queen, king, ace, 5 cards in order, all of the same suit. 10, jack, queen, king, ace, all of the same suit. How many different suits are there? So how many different royal flushes are there? 4. The combinatoric is just 4. Choose 1. Of the 4 possible royal flushes, choose any one of them. There's 4 royal flushes. 10, jack, queen, king, ace, in either hearts, diamonds, spades, or clubs. 4, choose 1 would just be 4. So 4 out of that same 2,598,960. Okay, let's look at straight flush. A straight flush is similar to a royal flush. It's 5 cards in order, all of the same suit. It's just the 4 I've already counted. It's extra. How many different types of straights are there? How many different ways are there to begin a straight? What's the lowest possible straight? Ace could be high or low. Ace, 2, 3, 4, 5. So I can begin with an ace all the way up to a 10. A straight can start with any number, ace 3, ace 2, 4, 5, 6, 7, 8, 9, 10, jack. There's our 10 different ways to start a straight. Choose any one of them. So 10 choose 1 tells me what type of straight I have. Do I have this straight starting with an ace? Do I have this straight starting with an 8? Do I have a straight starting with a 10? Whatever. So that makes it a straight. I also need it to be a flush. Flush means it's all of the same suit. All hearts, all diamonds, all clubs, etc. How many different suits are there? 10 choose 1 times 4 choose 1 would tell me how many different straight flushes there are. But that's counting too many. It's also counting the same royal flushes I've already got counted for up here in number 2. So we need to subtract off the 4 royal flushes from earlier. A straight flush excluding the 4 royal flushes already figured out. 10 choose 1 times 4 choose 1 would be 10 times 4 or 40 minus 36. There are 36 different straight flushes. 3, 4, 5, 6, 7 in all clubs, for example. So the probability of being dealt 5 cards that are a straight flush is 36 out of 2,598,960. Let's look at some more different possible poker hands. I'm going to slide this. 4 of a kind. I think this name is a little bit more familiar. What would 4 of a kind be? 8. All 4 of the jacks. So let's first make 4 of a kind. How many different kinds of cards are there? 13. There are 13 different kinds of cards. There are 13 ranked cards, anywhere from ace up to king. So let's pick one of the 13 kinds to have as 4 of a kind. I want all 4 of the 10s. I want all 4 of the queens. There are 13 different kinds of cards. I need all 4 of those. I'm going to multiply by 4, choose 4. Because I need all 4 of those kinds of cards. Does that make my 5-card hand complete? I've only got 4 cards. Don't I need 1 more? Mm-hmm. Okay. How many different kinds of cards have I already picked to make my 4 of a kind with? How many different kinds of cards are left? Well, choose 1. Pick the next kind of card to have as your last card, and I need any one of them. So choose any one of the 4 in that kind to have as the 5th card to make your 5-card hand. All right, calculate. One. Choose 4. It's 624 different 4 of a kind hands. Full house is kind of a weird name for a particular hand. Is anybody else? A full house would be 3 of a kind and 2 of a kind. I have a trio and a pair. So my 5 cards, there are 3 of a kind and 2 of a kind. 3 of a kind and 2 of a kind. Makes a full house. Well, let's build each of these parts separately and then multiply all of them together with our combinations. 3 of a kind. There are 13 different kinds of cards. I need to choose one of them to make my 3 of a kind with. How many of that type do I need to start my full house? 3. So I need, of that type, I need 3 of the 4 of them. There's the first combinatoric to get me the 3 of a kind to start my full house. Now I need the pair to make the other 2 cards. How many remaining kinds of cards are there that I could make my pair from? Oh. And I need exactly 2 of the 4 in that kind. King choose 1. Times 4 choose 1. times 4 choose 2. 3,744. So our probability is this ratio, 3,744 different ways out of 2,598,960 in total. Let's see, on the back page here, we've got some other different types of card hands. On the back page, a flush. What would a flush be? We've done a straight flush before. How is a flush different? All the same suit. Are they in order anymore? Don't have to, right? Because if they were in order, it'd be a different, right? So a flush is all 5 cards in the same suit. But keep in mind, I have to exclude the straight flushes. They have to be the same suit, but not in order. Let's pick the suit first. How many different suits are there? 4. How many cards are there per suit? 13. How many of them do I need? 5. So 3 choose 5 gets me 5 cards in that suit. But that's counting too many different hands. It's counting the hands that are also straight flushes, right? So I need to subtract off these straight flushes. 10 choose 1 times 4 choose 1. There's 40 different straight flushes that I've already counted for in here, but I don't want them. I've already got them counted. So minus 10 choose 1 times 4 choose 1. So choose the suit, 4 choose 1. Choose 5 cards from the 13 in each suit, but then we need to subtract off the straight flushes. And choose 1 times 20. So 5,108. I don't know what these are as decimals yet. It's probably not very likely. How about a straight? We've done straights before. What would a straight look like? What would a straight be in the 5 card hand? Straight is 5 cards in order. 9, 10, Jack, Queen, King. 3, 4, 5, 6, 7. It's a straight, but are they of the same suit now? Because if they were, it'd be a different hand, right? So let's think about the straights. How many different types of straights are there? How many different ways are there to start a straight? How many different hands can start a straight? 10. If I try and start it with the Jack, can I run out of cards? Jack, Queen, King, Ace, but then what's the 5th card, right? So I can start a straight with any card from Ace through 10. So let's pick the ways to start a straight. 10, choose 1. Pick the type of straight you want to build. How many cards make up that straight? How many cards are in a straight? 5. So I need the 5 cards that make up that straight. So 4 choose 1 to the 5th. I need 1 7. I need 1 of the 8s. I need 1 of the 9s. I need 1 of the 10s and 1 of the jacks. So I need 4 choose 1 5 different times. I need 1 of each of the types of cards in that straight 5 times in total. But of course, that's still counting too many because I'm counting these straights that are of the same suit to subtract off the 40 straight flushes from earlier. Then choose 1 that are of the same suit, so subtract those cards off, exclude those from the total. See here, 10 choose 1 times 4 choose 1 to the 5th for the 5 cards in the suit, but then subtract off the straight flushes that I've already got as a different hand. 10,200 would be the number of possible 5 card straights. Okay. What type of cards are in a 3 of a kind? What would a 3 of a kind hand look like? It's similar to a full house. Three of the cards are what? Same. How about the other 2 cards? They're not. So I have 3 of a kind and just other 2 random cards, right? So let's make the 3 of a kind first. How many different kinds of cards are there? And I can make a trio with. How many different kinds of cards? 13. And I need any 3 of the 4 from those 13. So 13 choose 1 times 4 choose 3. Now I need the other 2 cards to be something different. It can't be a pair. So I need all kinds of cards remaining, 2 different kinds. So I need to have like the 3 of a kind with like a 10 and a 2. I need 2 different kinds to make the other 2 cards in my hand. I need any one of those twice. I need a 10 and a jack, for example. I need a deuce and a 7, for example. So I need one of these 2 kinds twice. So 13 choose 1 times 4 choose 3. That's the 3 of a kind. Now I need 12 choose 2 to get the other 2 cards and one of each of them. 54,912. Out of that, just about 2.6 million. 2,598,160. What would that be as a decimal? We get anywhere close to a reasonable outcome? At a 2% chance you get the 3 of a kind in a 5 card hand. What is that? Only about a 0.5% chance you get dealt a straight. How about 2 pair? What would 2 pair look like? We got just a couple more hands. 2 pair would be what? 2 of the same card twice, right? So I have a pair of jacks and a pair of 8s and then some other card, right? So let's pick my 2 pairs. 13 kinds of cards. And I need 2 of the kinds to make my 2 pair with. So for that 2 pair, I need 4 choose 2 twice. I need 2 10s and 2 6s. So I need 2 of those kinds twice. The last card is just some other random card. How many other kinds of cards are left to make the random card left? How many other different kinds of cards are left if I already have the 2 pair spoken for? 11. So of the 11 kinds of cards remaining, choose one of them, and then choose one of any 4 of that kind. All right, so let's see here. 13 choose 2 times 4 choose 2 times 11 choose 1, and I need one of that kind. 123,552. It's 123,552 different 2-pair hands. Let's see. So that's about a 4.75% chance to get dealt 2-pair from the 5-card hand. Obviously, 1 pair is different because how many pairs of cards are in a 1-pair poker hand? just one set, right? One of 2. I have 1, 2 of a kind. What the other 3? They're just random numbers, right? They just can't match. So it'd be another pair. So let's make the 1 pair first. Choose one of the 13 kinds of cards to build the pair with. And I need 2 of the 4 to make the pair. So that leaves 12 different kinds. To make sure that the other 3 cards in my hand don't make pairs. Here's the combinatoric to make the pair. The other 3 cards can't be of the same kind. So I need 12 choose 3 to make sure that the other 3 cards don't match. And then of those 3 kinds, I need 1 of them. So I need 4 choose 1 for 5th card. And it was 12 choose 3 times 4 choose 1 to the 3rd. 1,098,240. Get that typed in? Yep. What was that? Maybe a little bit less than 50%? Maybe 40% or so? You're going to get dealt 1 pair. Percent. All right, this last one's a little bit different. I need a high card. I want to have all 5 cards of all different kinds. I want to have no pairs, where none of the 5 cards match. The lowest possible hand, just high card is the one that counts. How many different kinds of cards are there? Off 10 because I want to make sure that those cards also don't make a straight, because there's 10 different ways to start a straight. I also want to make sure that these cards, see, I need 5 of them, so let's do that first. 4 choose 1 to the 5th. That makes the 5 cards in my hand. I also don't want them to be of the same suit. How many different suits are there? 4, so we're going to subtract off. I need 5 different kinds of cards, but they can't be in order. So I need to subtract off 10. I need 5 cards in my hand, so that's 4 choose 1 to the 5th power. I don't want them to be of the same suit, so I need to subtract off 4, because there's 4 different kinds of suits. Not like in here. All right. This is the 1,302,540 cards remaining. Of course, you could have just added all of these different kinds of cards up. Whatever's left over makes the no pair outcome too, I suppose. What's that as a percentage? About 50%. 1,302,540. Yep, 50%. About half the time, when you dealt 5 cards, you're not going to have any pair. Let's take the last part of class. On the back, jump a little bit. Instead of 5-card poker, now you're playing 3-card poker. Let's take about 5-10 minutes. I want you to figure out in a 3-card game of poker, how many hands are possible? What's the probability that you're dealt a straight flush? That would be 3 cards in order, all of the same suit. What's the chance that you're dealt 3 of a kind? All 3 cards are of the same kind. Of the Yep. Quiz on Friday, I might give you a 3-card hand like this and say, what's the chance that you're dealt a straight flush? Or what's the chance that you're dealt a pair? Or what's the chance that you have 3 of a kind? Or maybe I'll do the same thing with a 4-card game of poker or a 5-card game of poker. Hand, what's the 4-card hand poker? You have 2 different pairs, perhaps. Make sure we're all on the same page. How would you do number 1? How many cards are in a deck? How many am I choosing? 3, right? Instead of 5, now it's 3. So 52 choose 3 tells you the number of different 3-card hands possible. So straight flush, how many different flushes are there? How many different types of suits are there? How many different, that's the straight part. We'll come to that in a minute. How many different kinds of suits are there? I'm reading off 4. 4, right? So it's 4, choose 1 to figure out what type of flush you want. Do you want a flush in hearts, diamonds, spades, or clubs? Now it's not 10 choose one. There's not 10 different kinds of straights in a 3-card game of poker. I can start a 3-card straight with anywhere from ace to what? Jack would be Jack, Queen, King. Could I make it a little bit higher? That's not the highest possible straight. I could go 10 Jack Queen. I could go Jack Queen King. I could go Queen King Ace. So I can start a 3-card straight anywhere from ace to ace 2 3 Queen King Ace. So how many types of straights are there? You could go ace 2 3. That's the lowest type of straight, right? All the way up to Queen King Ace. So how many different ways are there to start a straight in a 3-card game? I could go ace through queen. How many types of cards are there from ace through queen? Okay. So there's 12 different kinds of straights. Does that sound right? Yeah. There's 12 cards counting from ace up to queen. Well, there's no royal flush now in a 3-card game. So it's just a straight begin. Don't worry about royal flush. A royal flush is like a very specific 5-card. That only applies to 5 cards.
Suits, yeah, but
So it's just going to be 12 choose one. All different kinds of straights to pair with 4 different kinds of straights. Does that make sense? You can go from easy 3 all the way to 12 cards from ace.
it's 2 to 1.
So put the answers in. On my should be 48. Yep.
48 over 22.
Out of how many were there possible?
22,000.
Yeah. There's no royal flushes in a 3-card game. Royal flush is just only for 5-card poker. What's that probability? How many 1-pair hands are there in 3-card poker? What's that probability?
That's all the.
Three of a kind is a part of the 13 choose 1 times 4 choose 3. Is that right?
Would this 3 of a kind be the same as a third one?
3 of a kind means I need I need the 3 cards in my hand to be 3 jacks or 3 10s or 3 4s.
Yeah, wouldn't it just be the same as that one?
Which one? No, because in 3-card poker, you don't have to worry about what comes after this, right? Because I don't need the other 2 cards in my hand.
Yeah, so it'd just be the 13 suits.
Yeah, it's this- There's 13 different kinds of cards. Choose one of them, then choose 3 of the 4 in that kind. Makes sense to me. Let's see, 3 of a kind. Is that 52?
Yeah.
For a pair, that's 34. I got the answers up here in red if you want to check your work. I'll put up the combinations here. There are 52 different 3 of a kind 3-card hands there, and there are 3,744 different 1-pair 3-card hands. You have 1 pair in 3 cards. Make sure that your 3rd card doesn't match the other pair you already have. Let's see. We did the number of hands possible to get started. 52, choose 3. Five kinds of suits are there to make a flush in? Different kinds of suits. 4. So choose the suit first. I want a suit in spades or hearts or diamonds or clubs. All right. How many different kinds of straights are there in 3-card poker? From ace up to queen is how I can start the straight. I could go anywhere from ace 2, 3 for the lowest straight up to queen, king, jack for the highest straight. So how many different kinds of straights are there? Ace through that's 12 different cards. Choose one of those kinds of straights. Or choose 1 times 12. Choose one that's 4 times 12 or 48. All right. How about 3 of a kind? 13, and I need one of those kinds to make my 3 of a kind with. Of the 4 cards from that kind, choose 3 of them. 13 times 4, choose 3, should be 52. 13 times 4 makes 52. How'd you set up the 1 pair?
Of 13 cards, you need 1. And out of the 4 cards, you need 2.
Okay, so that fits with the pair.
And then you have 12 cards left. And then
Of the
out
12 left, choose 1. Sounds right to me. The first 2 combinatorics builds the 1 pair of the 3 cards in your hand to make sure that 2 of the 3 cards match. This combinatoric is to make the 3rd card not match the first. The 1 card remaining doesn't match the first. I'll choose 1, make sure that it doesn't match, or choose 1 of them from that.